Hi, I will be speaking about simulation approaches most suitable for the analysis of circular supply chains. My name is Saman Amer. I'm the co-founder of CirBES and leading the work on circular supply chains in the EU project that CirBES is part of. CirBES was founded in 2014 with a vision to create value for business environment and society simultaneously. We specialize in the implementation of circular economy principles, ranging from value proposition models, product design, and supply chains. Our portfolio consists of awareness and knowledge building workshops on circular economy, quick checks on circularity assessments, as well as in-depth assessments using simulations. We also offer experiential hands-on learning workshops with CirBES Game. Receps stands for Resource Efficient Circular Product Service Systems. This project is about large-scale implementation of circular economy, where two companies from white goods and automotive industry are implementing circular strategies. In addition to the companies, there are knowledge partners and SMEs in the project. In this project, CirBES is contributing with the work on circular value and supply chains, supporting the demonstrator with circular supply chain simulations that helps in decision making. So what are the most commonly used methods to tackle supply chain challenges? There are many ways to build quantitative models to support fact-based business decisions, particularly in the supply chain area. Most commonly used are Excel spreadsheets. The pros are that they have a widespread acceptance. They are simple to learn and apply. The cons can be limited application, especially with large data sets. It may also require advanced skills. The second way is analytical models. They can be used to find decision variables by using objective functions. The pros are that you can use linear equations, and the cons are that they are based on generalization and simplification, and supply chains are represented as continuous flows. The third method is the dynamic simulations. They can describe the dynamic behavior and interaction between different actors. The pros are that it can provide detailed representation of supply chain operations, and you can model time-dependent behavior such as delays. The cons are that it is often time-consuming to build such models, and it requires specialized user interface. Before going into the simulation techniques, I'll say a few words about the circular supply chains. Circular supply chains are driven by closing the loop by intention and design. A value proposition model complemented by a product design capable of multiple product life cycles and a suitable value recovery strategy are the cornerstones of a circular supply chain. This means that for these supply chains, there must be a seamless integration of forward and reverse flows. In a circular supply chain, the timing of products going into the market, returning from the market, and reintegration is crucial to lower cost and CO2. Medium abstraction level is best suited for circular supply chain analysis because it is not too time consuming, but it also generates sufficient insights at the same time. As many reverse infrastructure elements mostly do not exist today, hypothetical structures need to be evaluated under high uncertainty. Hence, one can start with analytical methods to tackle greenfield analysis, network optimization, and master planning. However, a more detailed level is needed to create insights on circular dynamics, especially considering the complexities of circular economy implementation. Randomness or uncertainty can be handled more effectively in a simulation environment. For example, deterministic model, example, a truck arrives on average every 3 days, is a simplification, which in reality can lead to misleading capacity plans. Probabilistic can better reflect reality, as events in real life are not evenly distributed. In simulations, one can choose different levels of abstraction that generates insights based on the question at hand. One can go to a very detailed process-oriented model using discrete event approaches, address medium-level details using agent-based approach, or understand trends and dependencies using system dynamics modeling approach. Adding to that, system dynamics operate at a high abstraction level and is mostly used for strategic modeling. Discrete event modeling with underlying process-centric approach supports medium and medium-low abstraction. Agent-based models can vary from very detailed, where agents are physical objects, to a highly abstract, where agents are competing companies or governments. If the phenomenon to be studied is complex, all modeling approaches can be combined as well. For instance, to model a circular supply chain, discrete event can be used for processes occurring within the facilities, system dynamics for the aggregated effect of the product flows between facilities in the supply chain network, and agent-based approach to monitor a system behavior evolving from agents with a set of rules acting independently in a predefined system. Models can be used to come up with best possible solutions in different scenarios. They provide a possibility to envisage real-world problems in a simplified manner to establish a sound basis for decision support with measurable parameters and indicators. A simulation model is a virtual version of reality, which we either want to analyze or create. Modeling and simulation can be used to assess circular systems in terms of costs, resource efficiency, and environmental impact. And at the same time, it helps in informed decision making. These tools can support decision makers in estimating new revenue streams, cost impact, investment potential of different business approaches, and identifying the most promising business models from both economic and environmental perspectives. Such models can serve as a decision support both in the design phase of a system as well as improvement of the system. As mentioned earlier, the choice of modeling method depends on the questions to be answered, the underlying phenomena to be studied, or to test different scenarios in a simulation and find out the best possible solution to be implemented in the real world. So how can one create a simulation model? Based on conceptual models, supply chain scenarios are developed and then tested. The simulation model is initiated by developing a conceptual model of supply chain structure, including the interactions and potential questions to be explored, followed by data collection and data synthesis. Next to that, the logic is developed for the interactions of agents in the simulation platform. Once the model is formed, the analysis can be performed for different business scenarios using what-if conditions and interactions. The model is then verified and validated for discrepancies, and finally, results with comparative scenarios are presented. This is an example of simulation model with actors in the GIS space. The boundary of supply chain is created by showing which entities are considered. You can also see data logs from the simulation runs based on the input cost parameters. This is just to show that with such simulation models, one can gain accurate cost estimates, capacity estimates, for instance, production planning and inventory questions. One of the major advantages of such models is that you can run complex multi-year scenarios in a few minutes and test your business solutions in a risk-free environment. In Receps project, we have two demonstrators from white goods and automotive industry, where the white goods demonstrator in this project will implement a pay-per-wash model for 300 customers in 4 European markets. The automotive demonstrator is based on the after-sales solutions, and in this project, the focus is to close the loop by using a single service provider and streamlining the logistics flow for 80,000 cores. Our upcoming webinars will discuss how simulations can support in decision making for the transformation towards circular value propositions. Thank you for listening. You're very welcome to contact me for questions and comments on this webinar or about our offers.